Good morning to all. Today we are going to discuss about the nutrition. So first of all, we should know what is nutrition means. So nutrition may be defined as the science of food and its relationship to health. It is concerned primarily with the part played by the nutrients in the body, growth, development and maintenance. Good nutrition means maintaining a nutritional status that enable us to grow well and enjoy good health. For an average person, a recommended dietary allowance, we say it RDA, has been established to provide standard for promoting and maintaining good health. However, nutritional requirements are much greater for athletes than the average population. Depending on the needs of the athletes, for example, size difference, gender difference, requirement of the sports, energy intake may be 3 or 4 fold higher than the recommended for the average individual. The nutritional needs of the athletes have been focus of much research concerning what to eat, when to eat, and which nutritional supplement to take in order to maximize performance. Next, we have to concern about the classification of the nutrients. There are about 50 different nutrients which are normally supplied through food we eat. Most natural foods contains more than one nutrient. This may divide into the macronutrients and micronutrients. Macronutrients. These are protein, fat, carbohydrate, which are often called the proximate principles because they form the main bulk of the food. In the Indian dietary, they contribute to the total energy intake in the following proportion: 70% from the carbohydrate and 25% from the fat we eat and 5% from the protein. Next, we consider about the carbohydrate, the main source of energy. Carbohydrate provides quick energy to the body and is not stored in the body for long. The basic unit of carbohydrate is monosaccharide. Carbohydrate is compound of carbon, hydrogen, and oxygen. And carbohydrates are two types: simple carbohydrate and complex carbohydrate. Sugar are simple carbohydrate, which are used to provide energy immediately. Monosaccharide are the simplest form of carbohydrate. They consist of one unit sugar molecule, such as glucose, fructose, galactose. Disaccharides are composed of two unit sugar molecules, such as sucrose, we mean it table sugar, maltose, grain sugar, and lactose, milk sugar. Which of these carbohydrates can be broken down to simpler form through the process of digestion. Both mono and disaccharide are considered simple sugar and are a good source of quick energy. Sucrose consists of the glucose and fructose molecules. Maltose consists of two glucose molecules, and lactose consists of the glucose and galactose molecules. However, for the galactose to be used as energy, it must undergo a secondary conversion of glucose. So, to increase the blood glucose level quickly, a glass of milk may not be an ideal, because simple carbohydrates are found in natural foods such as fruit and vegetable, as well as in processed foods such as candies and soft drink. And some source of simple carbohydrate are fruit, milk product, and vegetables like potatoes and carrots. Complex carbohydrate. And what are the complex carbohydrates? complex carbohydrates are good source of fibers. Starch is a complex carbohydrate that contains several sugar molecules combined together chemically. Carbohydrates that contain more than 2 monosaccharides are termed polysaccharide and are known as the complex carbohydrate. Common polysaccharides include starch and glycogen, which is made up primarily of chain of glucose molecule. The bond that bind the monosaccharide of the complex carbohydrate may be either digestible or indigestible. Indigestible polysaccharides are known as the fiber and are common in some grain, fruit and vegetable. Their energy content is higher than the sugar but released more slowly. Some source of complex carbohydrates, they are found in the bread, cereal, starchy vegetable and whole pulse. Let us consider about the function of carbohydrate. The 4 important functions related to energy, metabolism and exercise performance are: Number 1. Energy source. The main function of carbohydrate is to serve as an energy fuel, particularly during exercise. Number 2. Protein storing. Adequate carbohydrate intake helps to preserve the tissue's protein. Number 3. Metabolic primer. Carbohydrates serve as a primer for the lipid metabolism. Number 4. Fuel for the CNS. The carbohydrate is essential for the proper functioning of the central nervous system. Now we come to the recommendation. The recommended amount is 55 to 60% of total calories from carbohydrate, preferably from a complex carbohydrate. To increase the complex carbohydrate, we should eat more fruit, vegetable, whole grain, rice, bread, cereal, and some more beans, dry peas, and low-fat milk. Excess of carbohydrates are converted into the fat by the liver and stored in the adipose tissue. The consumption of the excess sugar reduces the performance and endurance of an athlete. So, proteins are the basic structure of living cells, essential growth and repair of muscle and other body tissues. It is a nitrogenous substance that are formed by the amino acid. The basic structure of protein is a chain of amino acid that contain carbon, oxygen, hydrogen, and nitrogen. In addition, they are used to produce hormone, enzyme, and hemoglobins. Protein can also be used as energy. However, they are not the primary source of an energy source. For protein to be used by the body, they must be broken down into their simplest form, that is amino acid. There are 2 types of amino acid. We call it 1. Non-essential amino acid and 2. Essential amino acid. Let's consider first about the non-essential amino acid. The human body needs approximately 20 amino acids for synthesis of its protein. The body can make only 11 of amino acids that are known as non-essential amino acid. Why we call it non-essential? Non-essential means that our body can synthesize them and they do not need to be consumed in the diet. They are essential, but we do not have to get them from the food we eat. Essential amino acid. The essential amino acid, there are 8 or sometimes in some particular adults and some children they require 9, cannot be synthesized by the body and therefore must be provided in food. Thus, they are called essential protein or amino acid. Absence of any of these essential amino acids from our diet prevent the production of proteins that are made up of those amino acids. Next, what we call it complete protein and incomplete protein. Complete protein is the protein of the food supplied in enough of the essential amino acid. And incomplete protein, if the protein of the food does not supply all the essential amino acid, it is called an incomplete protein. Source of complete proteins. All the meat and other animal products are source of protein. Source of incomplete proteins are grains, fruits, vegetables are the source of incomplete protein because they are lack of one or more essential amino acid. The plant protein can be combined to all the essential amino acid and form a complete protein also. Protein is the main compound of muscle, organs and glands. Every living cell and all body fluid except urine and bile contain protein. There are some functions of proteins. We say the importance of the proteins. Number 1, the cell of the muscles, tendons and ligaments are maintained with the proteins. Number 2, we need proteins to grow and development of the children. Number 3, it requires for the formation of hormones, enzymes and haemoglobins. Protein work as a source of energy in starvation. Example, when we are in hunger, and some special consideration about the proteins. High intake of the protein creates extra load on the body due to disposal of the nitrogen, especially for kidney and liver. Dehydration can occur because of disposal of nitrogen, which may affect workout. It is therefore important to have adequate water when consuming increased level of the protein. Next, we are going to consider about the fat. Fat is a highly concentrated fuel that has limited water solubility. Fat also referred to as the lipid. Lipid come from the Greek word lipos, the same meaning with fats. Fat exists in our body in several forms. Lipid is general terms that include oil, fat and wax. Oil are liquid at the room temperature, which fat remains solid. Fat contains carbon, hydrogen and oxygen. The basic unit of fat is the fatty acid, which is also the part of fat that is used for the energy production. The most common form of lipid is the triglyceride, which is composed of 3 fatty acids and a glycerol molecules. Approximately 98% of the dietary fat is in form of triglyceride, and about 90% of the fat in the body is stored in the adipose tissues depot, mostly in the subcutaneous tissues. Another common lipid is cholesterol. We have classified fat as a simple fat and compound fat. Simple fat. Simple fat consists of glyceride molecules linked to 1, 2 or 3 units of fatty acid. According to number of fatty acids attached, simple fat are divided into monoglyceride, that is 1 fatty acid attached, diglyceride, 2 fatty acid ATAs, and triglyceride means 3 fatty acid ATAs. More than 95% of the stored fat in the human body is in form of triglyceride. Based on the degree of hydrogen saturation, fatty acids are said to be saturated and unsaturated. In saturated fatty acid, the carbon atoms are fully saturated with the hydrogen atoms. Therefore, only single bond link the carbon atom on the chain. The saturated fatty acid frequently referred as the saturated fat. Saturated fatty acids tend to be solid at room temperature and are generally derived from the fat of animals. The consumption of the saturated fats is also associated with a great risk for cardiovascular diseases like heart attack. In unsaturated fatty acids, the carbon atoms are not completely saturated with the hydrogen atom. Rather, double bonds are formed between the unsaturated carbon atoms. These are generally found in the plant products. Unsaturated fatty acids have at least one or more monounsaturated if one double bond is there, and polyunsaturated if double bond or more bond is there. And fatty acids, unsaturated fatty acids tend to be liquid at room temperature. Polyunsaturated fatty acids are primarily found in the vegetable oils and are preferred source of fat for lowering the risk of the cardiovascular diseases. There are some important notes. Saturated fatty acids increase the blood cholesterol level, and polyunsaturated fatty acids tend to be decrease the cholesterol level. And next, we come to the point about the compound fat. Compound fats are combined of simple fat and other chemicals like phospholipids, glucolipids, and lipoproteins. Lipoproteins transport fats in the body and have a significant role in the development and prevention of the heart diseases. We say HDL, that is high density lipoprotein. We call it the good cholesterol. And LDL, low density lipoprotein, that is the not good for our heart. Functions of the fats. Number 1, fat helps proper functioning of the body. Number 2, importance for the energy source. That is, it provides 70% of total energy during the resting state. Number 3, support and caution vital organs. Number 4, make up essential components of cell membranes and the nerve fibers. Number 5, serve as a precursor for the steroid hormones. Number 6, fatty acids provide the raw materials, help in control of the blood pressure, blood clotting, and other body functions. Number 7, fat maintain skin and hair. Number 8, store and transport fat-soluble vitamins like A, D, E, and K. Number 9, serve as an insulator to preserve body heat. Now let us come to the point, micronutrients. Micronutrients are the vitamins and minerals. They are called micronutrients because they are required in the small amount. Vitamins are the compound of carbon that are absolutely essential for the normal working of the body. It needs by the cell to perform specific functions that promote the growth and maintenance health, including enable cell to utilize carbohydrate, fat, and protein for the energy. 13 different vitamins have been isolated, analyzed, classified, and synthesized, and recommended dietary allowance level have been established. Vitamins are classified as either water-soluble or the fat-soluble. The fat-soluble vitamins include vitamin A, D, E, and K. Once absorbed, they are bound to the lipids and transported throughout the body. Excess fat-soluble vitamins are stored within the fat store of the body, and excessive intake of fat-soluble vitamins can be cause toxic accumulation. Water-soluble vitamins. Water-soluble vitamins include vitamin thiamine, that is B1, riboflavin B2, niacin B3, pyridoxine B6, cobalamin B12, and vitamin C. Water-soluble vitamins are not stored by the body. Once absorbed, are transported throughout the body in water. Water-soluble vitamin functions largely as coenzyme, which are small molecules that combine with the large protein compounds to form active enzymes that accelerate the interconversion of chemical compounds. In general, any excess of the water-soluble vitamins is excreted in the urine. Special consideration for vitamins. Number 1. Vitamins are essential for the metabolism of fat and carbohydrate. Number 2. Vitamins do not yield energy. That means vitamin doesn't create any energy to our body, but act for repairing and maintenance of body. Number 3. Water-soluble vitamin B and C are not stored in our body. Thus, supplement of the vitamin B and C is required. Number 4. Fat-soluble vitamins means A, D, E, and K can be stored in liver and fatty tissue. Vitamins do not increase physical work capacity. Rather, it is a psychological concept. Number 6. Vitamin E help recover of the muscle cramp. 7. During the training, fresh fruit and vegetables are recommended. Next is come to the point, minerals. Mineral contains elements needed by our body in small quantities, but these are essential for proper growth and functioning of the body. Approximately 4% of the body's mass, that is about 2 kg for a 50 kg weight woman, is composed of a group of 22 mostly metallic elements collectively called as minerals. Minerals are constituents of the enzyme, hormone, and vitamins. They are combined with other chemicals, for example, calcium phosphate in the bone, and iron in the heme of the haemoglobin, or exist singularly, such as free calcium in the body fluids. Their deficiency in our diet causes deficiency diseases. They are supplied in form of salt in different foods. Any excess minerals are useless to the body and even may be toxic. Some special consideration for the minerals. Number 1. Minerals are essential for strenuous physical activity. Number 2. Supplementation of iron is must in the female. Number 3. Supplement of the calcium and phosphorus may be given to young athletes. Lastly, the nutrients, we call it water. Water makes up of 40 to 60% of individual's body mass and constitute 65 to 75% of weight of the muscle and approximately 50% of the weight of the body fat. The body has two main water compartments, that is intracellular and extracellular. Of total body water, an average of 62% is intracellular and 38% is extracellular. Functions of body water. Water is a remarkable nutrient. Without water, death occurs within days. It serves as a body transport and reactive medium. Diffusion of gas always takes place across the surface moistened by water. Nutrients and the gases are transported in the aqueous solution. Waste products leave the body through the water in urine and feces. Water has tremendous heat stabilizing qualities because it can absorb considerable heat with only a small change in temperature. Water also lubricates joints. Normally, approximately 2.5 liters of water is required each day for a fairly sedentary adult in a normal environment. This water is supplied from three sources. Number A, from liquids. Number B, inputs. And number C, during metabolism. Let us come to the conclusion. Nutrition may be defined as the science of food and its relationship to the health. It is concerned primarily with the part played by the nutrients in the body growth, development, and maintenance. However, nutritional requirements are much greater for the athlete than the average population. The nutritional needs of an athlete have been focus of the most research concerning what to eat, when to eat, which nutritional supplement to take in order to maximize athlete performance.